Alright, so in this video we go over section 7.3, which is analyzing and writing equations of the ellipse. Well, first of all, we are going to define what the ellipse is. So an ellipse is the locus of all points in the plane, the sum of whose distances from two fixed points called foci. So foci, we must say that's the plural of focus. So like in the parabola had one focus. Well, the ellipse will have two foci, which is this one right here and the one right there. So those distances, the sum of those two distances are the same. So, all right. So what do we mean by those two distances being the same? Well, first let's see how we can draw an ellipse. So if we take two thumbtacks, right here, you can put them right with a, then use a hammer, and then take a piece of string, but being sure that the string's length is larger than the distance between the two thumbtacks. Right, then we're going to grab a pencil and then we're going to draw this geometric figure which corresponds to kind of an oval. Well, we don't call it oval, it's called ellipse. So what the thing here is, if we, okay, let me draw an ellipse here. Okay, so it's not the best picture. So for example, if I call this D1 and this D2, D1 plus D2 will be some number, whatever the number is. So let's say, well, no, let's not put numbers. Let me call it a constant. Also, if I draw another ellipse and its corresponding foci, let's say this time I put them over here. This D1 and D2 will also be the same. Whatever you put the pencil, like on the picture above, right here, this distance, D1 and D2, if you add them together, no matter where the pencil is, that distance, those two distances add up to a constant. Okay, so we are going to analyze two types of ellipse. Well, first of all, we're going to look at ellipses with center at the origin, and then the translated ellipses. So an ellipse center at the origin, well, let's look at its properties. So it's going to have a center, which is 0, 0. These 2 points that are going to be the foci. And notice that the ellipse has a form very similar to that of a circle, except that it's a little bit smashed. So for that reason, we are going to find two axes. This is the minor axis, and this will be the major axis. The end points along the major axis are the vertices. So this is vertex. This is another vertex. On the other hand, well, what about the other 2 points? Do we call them vertices as well? Well, no, we don't call them vertices. Although the book doesn't talk or doesn't even look at these points, well, other books or other resources, if you look on the internet or even on YouTube, these are called co-vertices. So co-vertex and another co-vertex. All right, but we're not going to look at these points. So, but I mean, it's worth mentioning them. Okay, it's important just as a matter of vocabulary. So when you do the homework, you may not be asked for the co-vertices in this case, or maybe on a quiz or maybe on an exam I will ask you to find those co-vertices, but at least not on the homework. All right, so let's look at our first case of ellipse. Well, so suppose that we don't have this a squared and b squared. If you recall, we are going to have x squared plus y squared equals 1. That's the equation of the circle. However, in this case, um, a and b will correspond, will be related to their length um, of their major axis and the minor axis, which in this case, the length, this length right here from co-vertex to co-vertex will be 2b, 2 times b, because from the origin we move 2 units up. I mean, we move b units up and b units down to reach the other co-vertex. However, for the vertices, which are actually labeled here, notice the co-vertices are not labeled, they're just labeled as points, but they're not as they are co-vertices, but that's how we call them actually. But for the vertices, well, we move a unit and to one side to the right and a unit to the left. That's why we have the minus and the plus, and that's how far will the ellipse will extend. All right, so every time that we look at an equation of an ellipse, how do we know that the equation of the ellipse will be that of an ellipse that opens, or that is actually a horizontal ellipse? Another way to say horizontal ellipse, major axis is the x-axis. Notice the major axis is the x-axis. So the largest of the denominators, which is a, is the denominator of the variable x. Because notice here this inequality, a is bigger than b. In this case, that's what we are assuming, that a is greater than b. So, and just like we did in the previous section with parabolas, on top of the vertices, we're going to find the foci. Now, how do we find the foci? Well, let me go back to the previous page, to the previous image. So again, if we keep moving our pencil, we are going to, we can use that fact. We can use that and place the pencil in a very convenient place. What do I mean by convenient place? At a place where in this case, well, this is the center, this is D1, D2, but the thing is, the distance from this, what I'm going to do here is to take this triangle. I'm going to take this triangle. Okay, so the distance from the origin to the co-vertex, that's B. So the other distance, this is going to correspond to A, and C will be the distance from the center to the focus, which is the focal distance. And we can use the Pythagorean theorem to find that focal distance. Well, so using the Pythagorean theorem, b squared plus c squared equals a squared. Be careful, because you may know the Pythagorean theorem using a different arrangement. So in this case, we use this arrangement. C squared equals a squared minus b squared. That's the formula that we are going to use to find the distance from the center to the focus. Well, right now it's a lot of pictures and a lot of symbols, so let's go ahead and do an example that actually, so we can see how this goes. Okay, find the equation of the ellipse with center at the origin one focus at 3, 0 and a vertex at negative 4, 0. Then graph the equation. Well, what are we going to do here? All right, so when it comes to analyze, we're finding the equation and also analyzing. We need to write pretty much all the information related to it. So, for example, center. The center is the origin. The origin. Foci. That's the plural of focus. So they're telling us that one of the focus is 3, 0. Okay, which is what I'm going to start plotting those points. The foci, the focus, the center. So the center is the origin. The one of the focus is 3, 0. But because in this case this is center at the origin and ellipses are symmetric, the other focus will be the point negative 3, 0. All right, so let's write that one down. Negative 3, 0. So vertices. They're telling us that one of the vertices is negative 4, 0. By symmetry, 4, 0 is the other vertex. Okay, so and is there anything else that that we need to write down? Well, maybe the co-vertices, but we can write those down at the end of this. Okay, I'm gonna leave it here. Co-vertices. Okay. Now, but in order to find the co-vertices, I need to find the distance from the center to the endpoints of the minor axis. So in this case, we have the length of the major axis. Okay, so let's see. First of all, let's write down all the A, B, and C, where A is the major length, the length from the center to the vertex. That is how many units we have. 4 units. B is the distance from the center to the endpoints of the minor axis, which we don't know. We are going to find that out. C, it's going to be the length from the center to the focus, which is called the focal distance. All right, it's called the focal distance. That is 3 units. And we're going to find out what this is, what B is. In order to find what B is, we're going to use the formula that I showed you earlier here. C squared equals A squared minus B squared. Okay, so let's see. So C squared equals A squared minus B squared. And so C squared is 3 squared equals A squared minus B squared. Okay, so C squared, which is 3, A squared, which is 4. So we are going to obtain 3 squared, which is 9, and 4 squared, which is 16, equal and minus B squared. Okay, so I'm going to subtract 16, and I'm going to get negative B squared equals negative 7. And then I'm going to divide both sides by -1 to get b squared equals negative, equals actually positive 7. So b will be plus minus the square root of 7. So this is going to go here, the square root of 7. That means we are going to move up square root of 7 units and down square root of 7 units, which will be approximately, well, using a graphing calculator. Let's go ahead and do it. Let's see, square root of 7, that's 2.65. So 2.6 roughly, so I'm going to move 2.5 roughly, 2.6, 2.5 roughly, 2.6. So that's how we are going to draw our ellipse. Co-vertices, well, okay, vertices, one of them is negative 4 comma 0, actually positive 4 comma 0, negative 4 comma 0. The center, which is the origin, 0, 0. The co-vertices are going to be 0 square root of 7, 0 negative square root of 7, okay, which are worth writing. 0 negative root of 7 and 0 root of 7. And foci, well, we already have them here. This is negative 3 comma 0 and 3 comma 0. This is all about this ellipse. And now let's write down its equation. So the equation that corresponds in this case is of this form. So let's write it down first. X squared over a squared, that's an a, not a 9, a, plus y squared divided by b squared equals 1. So in this case, a, which is 4, but 4 squared equals 16 plus y squared over the quantity b squared. Well, we have it here. B squared equals 7 equals 1. And that's the equation of this. All right. Now let's analyze the following equation. For example, to analyze the equation, x squared divided by 25 plus y squared divided by 9 equals 1. If you notice, well, the largest denominator in this case, it's below the largest of the denominators is that of the variable x, so that means it's going to be a horizontal ellipse, or an ellipse that has a major axis along the x-axis. Surely we're going to look at parabolas that in which the y variable has the larger denominator. Those are going to open up. But for this case, we're going to have one that opens to the sides, or it's horizontal, or the major axis goes along the x-axis. All right. So let's see. So in this case, this is going to be our a squared, and this is going to be our b squared. From here, we are going to get that a will be the square root of this number, which is 5. B equals the square root of 9, which is 3. C, well, we don't know. Let's find out. We're going to find out using the formula to find the focal distance. C squared equals a squared minus b squared, which in this case, c squared equals a squared, which is 25, minus b squared, which is 9. 25 minus 9, c squared equals 16. And c will be the square root of 16, which equals, well, plus minus. It doesn't matter if we don't write the plus minus. Is 4. So C equals 4. Now, let's first of all, let's plot all these points. So first of all, we know that the center is the origin. Okay, so A is the number of units along the major axis. So in this case, 5 units. By symmetry, -5. The minor axis is related to the quantity B. So in this case, 3 units up, 3 units down. So we can draw our ellipse. All right. And then C is going to be our distance, our focal distance. That is the distance from the center to the focus, which is going to be here and there. All right, so center. Center is the origin. We don't have those translated ones yet. Vertices. The vertices are these endpoints right here. That is 5, 0, -5, 0. All right. Or -5, 0, 5, 0. And then we have the covertices, which again, on the homework you won't be asked the code for the covertices, but again, it's important to have that vocabulary. Covertices. And then that's going to be the points located above here. So 0, -3 and 0, 3. Okay. And what else? Oh, the foci, which one of them is 4, 0 and -4, 0. And that's all we need to state for this ellipse. Okay. So in a nutshell, well, we're given the equation of the ellipse. Identify A and B by taking the square roots of the denominators. All right. And we'll find the focal distance by using the formula c squared equals a squared minus b squared. Find c, and then you have pretty much everything to finally graph, point the important points. Okay. Now let me go back a little bit to look at minor axis. Minor axis, that is the length. I'm going to abbreviate L. This is length of the minor axis. Well, we go from the center 1 to, well, that's actually 2 times b, which is 2 times the square root of 7. And the length of the major axis, which is 2 times the length from the center to the vertex, which is a, that is 2 times 4, which equals 8. So 8 units is the length of this major axis, and 2 root of 7 is the length of the minor axis. Let's look at the one. So length of the minor axis, that is 2 times b, and length of the major axis, which is 2a. So 2 times b, which is 2 times 3, which is 6, and 2 times a, which is 5, which equals 10 units. So the distance from vertex to vertex is 10 units. The distance from co-vertex to co-vertex is 6 units. All right, let's move on to the next topic. In this case, ellipses that have center at the origin, but also but in this case they open up. Actually, the major axis is vertical, not horizontal. And now you can see a difference in the form of their equations. So as opposed to the previous example, to the previous topic, well, we have the largest denominator denoted with a in the denominator of the variable x. In this case, for this type of ellipses that are vertical, we have the largest denominator being that of the variable y. So let's look at a couple of examples here. Okay, so let's see. Analyze the equation 9x squared plus y squared equals 9. All right, so one thing that we need to observe is that this equation, it's not in the correct form. Okay, so first, that is, we need to make sure the right hand side is a 1, and in this case it's not a 1. In order to do that, divide by whatever number you have on the right hand side, which in this case is divide both sides by 9. All right, divide both sides by 9. Now, this is going to give us the equation x squared. Let me write down x squared over 1. It would be a good idea. Okay, it would be a good idea, and then plus y squared divided by 9, and then 9 divided by 9 is 1. All right. So now from here we will be able to identify our A, B, and C. Okay, so first of all, let me see where I got my papers here. Where did I put everything away? So A, B, and C. So A in this case is the square root of the largest denominator, which in this case is 3. B is the square root of the smallest denominator, which in this case, well, the square root of 1 is 1. And C is our focal distance, which we are going to figure out what that is. Okay, so we're going to use the formula C squared equals A squared minus B squared, where A squared, that quantity squared, is a 1, and B squared is a number 9. Okay, actually it's the reverse. It's a 9 minus 1. You know, the largest goes first and then the smallest one. And that's going to give us 8. And in this case, well, C will be the square root of 8. And every time you have a radical number, you be sure to simplify. This can be simplified to 2 square root of 2. How did I simplify that? Well, square root of 8, that's the same as factoring the number 8 and get 4 times 2. And then use the properties of radicals that say that the radical of a product is the product of its radicals. And then to take the square root of the one that it's possible to take, like in this case, the square root of 4, which is 2, and then root of 2, which is what I have here. Alright, so we have pretty much everything here to graph and analyze the equation. Well, first of all, let's write down our center. So we are given that the center is the origin, 0, 0. And then, well, from the center, I'm going to move up 3 units, but in this case, not horizontally, but actually vertically. You know, the largest denominator is related to the y variable. So in this case, I'm going to move 3 units up and 3 units down. And then for the length of the minor axis, 1 unit and 1 unit. Also, we need to place our foci. Well, our foci is located at 2 root of 2, which using a calculator. Okay, let's go ahead and check how much is that. 2 times the square root of 2. 2.82, okay, 2.8, almost 3. So 2 point, I'm going to put it here, and I'm going to put it there. All right. So, and let's write down the coordinates of each of them. So the vertices, keep in mind that the vertices are the endpoints along the largest axis or the major axis. So the vertex is negative 3, 0, comma negative 3, and 0, 3. The covertices are going to be 1, 0, and negative 1, 0. And foci, one of the focus will be 0 to root of 2 and 0, negative 2 root of 2. Okay, let's list everything here. Okay, so center, vertices. The vertices are 0, negative 3, and 0, 3. The co-vertices are going to be negative 1, 0, 1, 0. And foci, that is plural of focus, one of them is 0, negative 2 root of 2, and the other one is 0 to root of 2. Right, and we're done analyzing this equation. So notice the two types of problems that we are going to run into when doing conic sections. In some cases, you will be given the equation and you get all the information out of it. Suppose that the next example in which they're giving us information, well, our job is to get the equation and graph them. In all cases, actually, in other cases, graphing it. So find the equation of the ellipse having one focus and both vertices, and then graph the equation. Well, center, vertices, co-vertices, foci. Okay, so the center, which is the origin, is given, right? Well, it's given right here. Even if they don't tell us, I mean, find the midpoint between these 2 points, 0, -3, and 3. The point right in the middle is the origin. Okay, so the vertices are 0, -3, and 0, 3. And one of the focus is located at 0, 2. So by symmetry, the other one is at 0, -2. All right. So from there, we are going to state our A, B, and C. Recall that A is the distance that goes from the center to the endpoints of the vertex, which in this case from 0 to 3, there's 3 units. B is the distance that goes from the center to the co-vertices, but we don't know that one. We will figure it out. But we know C, which is the focal distance. That is the distance from the center to the focus, which in this case is 2 units. All right, 2 units. So we're going to use our equation C squared equals A squared minus B squared, in which we're going to have C squared, that's 2 squared, equals A squared, which is 3 squared, minus B squared. That's going to be 4 equals 9 minus B squared. 4 minus 9, that's going to give us -5 equals -b squared, where b squared equals 5, and b will be the square root of 5. In this case, 5 is prime number. It's a prime number, so we don't need to decompose the number the same way we did it with the previous exercise here in the square root of 8. So let's see. So we're going to have the square root of 5. All right, if we square this, well, we need to ultimately we need to square A, that's 9, and we need to square B because we're going to need them for the equation. So in this case, the equation, notice it's a vertical ellipse. Our equation is going to be of the form x squared over b squared plus y squared over a squared equals 1, where in this case, x squared over b squared, which is 5, plus y squared over a squared, which is 9, equals 1. So that's going to be our equation. Now we need to verify what the square root of 5 is. We need to check what the square root of 5 is to find out, to give us an idea of how far will the ellipse open along the horizontal axis, right? So 2.23, basically somewhere here, 2.2, -2.2. Something like this. Okay, let's state the vertices, -3, 0, actually 0, -3, 0, 3, and then square root of 5, 0, and negative square root of 5, 0. And for the foci, we are going to have 0, 2, and 0, -2. And for the origin, 0, 0, which is the center rather. So vertices are, okay, I mean, they're given, but it's okay to rewrite them again. 0, -3, 0, 3. Co-vertices, negative root of 5, 0, root of 5, 0. Foci, 0, -2, 0, 2. Now, before moving on to the next topic, well, let's go back to both examples and find the length. of the minor axis, which in this case is 2b, which is 2 times 1, which is 2. And it goes 1, 2 units. That's the minor axis. And the length of the major axis which is 2a. That is 2 times 3 units, which is 6 units. If we count them, 1, 2, 3, 4, 5, 6 units. All right, let's move on to the next example. The length, minor axis, which is 2 times b, which is 2 times the square root of 5. The length, on the other hand, of the major axis is 2a, which in this case 2 times 3, which is 6. All right. It's important to know because more often than not, exercises will give you information about the length of the major axis. Otherwise, not the points, but rather information about the major axis and minor axis. All right, so let's look at next example. So page, where am I? So now we are going to look at ellipses that are not centered at the origin, that are centered at HK. And well, in this case, well, the pictures are going to be like this. The equations are going to be the same equations, for ellipses that are parallel, whose major axes are parallel to the x-axis. The largest denominator will be that of the variable x. That is for horizontal ellipses. For vertical ellipses or parallel to actually there's a little typo here, y-axis, the denominator, the largest of the denominator will be that of the variable y. And in this case, well, what are we going to be? We're going to have here vertical major axis or vertical ellipses. So in all this, the foci vertices, I mean, you don't have to memorize all these other pairs with letters. You will see this going on the examples. All right, so let's look at our first example. Find an equation of an ellipse with center at 2, -3, one focus at 3, -3, and one vertex at 5, -3. All right. First of all, let's plot the points that are giving us in the information. So center. Okay, center. Center is 2, -3. 2, -3. All right. 2, -3. And one of the focus is at 3, negative. Okay, that's the center. The focus, I was supposed to paint them with purple. 3, -3. Okay. And one vertex is at 5, -3. By looking at these points, notice they are all passing through this imaginary horizontal line that I'm tracing. That means this is going to be an ellipse whose major axis is parallel to the x-axis. In other words, we're going to have a horizontal ellipse which will be of this form, the one that has the largest denominator being that of the variable x. Okay, so let's see. So, okay, center, vertices, what else? Foci, and covertices. Okay. All right, so let's get other points. Let's use as the symmetry, and let's get A, B, and C. Okay, again, A is given by the distance from the center to the vertex, which in this case, the vertex is at 5, -3. Well, it goes, so from the center to that point, how many units do we have? 1, 2, 3 units. B will be the distance from the center to the co-vertices, which we don't know. However, we know the focal distance, which is 1 unit. That is the distance from the center to the focus. That's 1 unit. So by symmetry, I'm going to go -1 unit. And by symmetry, for the other vertex, I'm going to go from the center. I'm going to move 1, 2, 3 units. All right. Now let's find the quantity B using the formula. C squared equals A squared minus B squared, where C squared, that's 1 squared, equals A squared, which is 3 squared, minus B squared, that's 1, equals 9 minus B squared. B squared, very similar to one example we already did, that's 8. And B will be the square root of 8, which is 2 times the square root of 2. All right. And 2 square root of 2, let me do that again on the calculator. I think I have it here. It's 2.8 units. Almost 3 units, but not quite. 2.8 units. So I'm going to go 2.8 units. 2.8 units. It's almost a circle, this one. But not quite a circle. It's almost a circle. It's still an ellipse. All right. So B is 2 square root of 2. I'm going to need A squared, which is 9, and B squared, which is, don't spend time squaring this, just use 8. All right, so vertices. One of the vertices is, this point is going to be -1, -3. -1, -3, and then 5, -3. The co-vertices, okay, let's write those down. -1, -3, and then 5, -3. Up and down for the co-vertices, we're going to use pink. That's going to be, well, it's going to be interesting. This point is so I'm going to subtract 3 from, I'm going to subtract 2 root of 2 minus 3. And that's going to be a very interesting number. You know what? I'm not going to state the co-vertices here because the numbers here are going to go really, really nasty. All right. However, okay, let me just give you one. So it's going to be all the total 3 minus 2 root of 2. The co-vertices. And -3 minus 2 root of 2. Really nasty numbers. Okay, why not? Let's state them. So first, co-vertices. That's one of them is 2 comma, -3 minus 2 root of 2. And the other covertex is 2 comma 3 minus 2 root of 2. Foci, that's going to be 3 negative 3, which is already given. And the other one, 1 negative 3. Now we need to write down the equation. Well, so the form that corresponds is x minus h, quantity squared, divided by a squared, plus y minus k squared divided by b squared equals 1. So in this case, from the center, this is h, this is k. So we are going to have x minus 2 squared over a squared, which is 9, plus y minus negative 3, that's going to be y plus 3, squared over 8. And that equals to 1. All right. And let's do one last example. Right, this example is going to be really interesting because this is going to put a lot of the techniques that we have done throughout the semester. You might remember those examples that we did when we covered the equations of the circle, covered circles, and we needed to complete the square on both variables x and y, and that is precisely what we are going to do here. So first of all, let me write down this equation on the space below here. I'm going to use I'm going to write it down. So that's 4x squared plus y squared minus 8x plus 4y plus 4 equals to 0. Number one, what I'm going to do is I'm going to group x's with x's and y's with y's. And then I'm going to move on the next step, this 4 to the right hand side. So 4x squared minus 8x plus y squared minus 4y plus 4 equals to 0. So here I really didn't do anything interesting other than just ordering the terms. Now I'm going to subtract 4 to both sides to get 4x squared minus 8x plus some number, the number that, well, not yet, never mind. Forget about the plus number. Let's see. Plus y squared minus 4y equals negative 4. So what am I going to do? Okay, to complete the square, I would add just a number here. However, it's not going to be the case for the x side. Okay, so first, I need to make sure that the leading coefficient for x, well, the leading coefficient for the variable x is 1. So what I'm going to do, I'm going to factor the leading coefficient 4 times x squared minus 2x, and then I'm going to add a number here. Right, I'm going to add a number plus y squared minus 4y plus another number equals negative 4 plus, okay, be careful here because when I add a number, that number is being multiplied by 4. So be sure to add 4 times, boom, whatever number, and then over here Well, in this case, this number that I'm adding, this extra number, is not being multiplied by anything, so plus number. All right. So let's find out the magic numbers, those numbers that complete the square. In this case, 2 divided by 2 and then squared. That's a 1 squared, which equals 1. On the other hand, 4, which is this number, divided by 2 squared. That's 4 divided by 2. That's 2 squared, which equals to 4. 4. All right, notice something interesting here. What's going to happen? Negative 4 cancels with any of these 4s. Whichever you want to cancel it with, that's fine. And then what's going to happen? I'm going to have 4 times the factor form of this perfect square trinomial, which is x minus 1 squared, because that's the square root of the first term, the sine of the middle term, and the square root of this second term. The square root of 1 is 1, and then plus square root of y squared, which is y sine of the middle term, and the square root of the second term, which is 2. Quantity squared, that equals to 4. However, this equation is not in the correct form. We need to make sure that the right-hand side has a 1. In order to do that, I'm going to divide both sides by this number, which is 4, in order to get x minus 1 over 1, that's quantity squared, plus y minus 2 squared divided by 4, which equals to 1. And if you observe this equation, which variable has the largest denominator? In this case, if you observe, it is the y variable that has the largest denominator. That means this ellipse will have a major axis that is going to be parallel to the y-axis. It's going to be, in other words, a vertical ellipse. All right, so from here, I think it's a good, I think we can analyze everything. So center. The center, which is located at 1, 2, and vertices, foci. Maybe I will do the co-vertices depending on how ugly the numbers are. I'll figure it out. Okay, so vertices we don't know. We will find out. So from here, A equals to 2, and from there, B equals to 1. Okay, let me list A and B above. So A equals to 2 and B equals to 1. We need to find out what C is. Using, again, we're going to use the formula to find C. So C squared equals A squared minus B squared. So C squared equals A squared, which is 2 squared, minus B squared, which is 1 squared. That's a 4 minus 1, so C squared equals the square root of 3. Yeah, it's kind of an ugly number here. Okay. So I shouldn't have added the root symbol yet. Just the number 3. C equals the square root of 3. Never mind. All right. So let's see. I'm going to start by plotting the center, which we stated here already. That's 1, 2. All right. Looks like I have a, you know what, I think I messed something up. Okay, let me go back to the equation. I've just realized I changed this plus for a minus. This is supposed to be a plus, plus plus, and then this becomes a plus, this becomes a plus, and this 2 becomes a negative 2. Otherwise, it was not going to work. So 1, negative 2. 1, negative 2 is our center. And then let's see. From here, let's see. So the vertices are going to be located 2 units away from the center in the vertical direction. That is 1, 2. One is going to be here. The other one is going to be 1, 2. It's going to be there. The endpoints of the minor axis, that is the co-vertices, well, yes, I think we're going to be able to state the co-vertices because are going to be nice looking order pairs. And the foci, which is square root of 3 units away from the center. All right. Square root of 3 units away from the center, which, by the way, the square root of 3, that's a 1.7. So I'm going to go 1.7. That's roughly here, and then 1.7, roughly there. All right. So let's see. So we were analyzing this, right? So let's go back to our list, vertices. Okay, let me write them down here. One of the vertices is 1, negative 4, and 1, 0. All right? So 1, negative 4, 1, 0. Foci. Okay, so in this case, I'm going to have 2. Okay, so this is the number, actually, negative 2 minus root of 3, and then minus root of 3. So let's see. Let me see what I have here. Okay, so negative 2 minus root of 3 and negative 2 plus root of 3. So it's going to be, let me state them here first. Negative, actually, 1, comma, negative 2 minus root of 3 and 1, negative 2 plus root of 3. Those are going to be the coordinates of the foci. Okay, let me write them down here. 1, comma, negative 2 plus, actually, if I'm going to do the minus here, minus root of 3, and 1, negative 2 plus root of 3. Okay, and co-vertices, well, in this case, these are nice numbers. The co-vertices are going to be these points 0, negative 2, and 2, negative 2. That I'm going to take over here. 0, negative 2, and 0, actually 2, negative 2. All right, and this pretty much covers this topic, what I wanted to cover. However, I'm going to make up another example in which that more often than not you may see either on the homework, on a quiz, or on an exam, you know, depending. So let's see, find the equation of the ellipse centered at, I don't know, let me come up with a point, -3,7, for example. I don't know. And with major axis length as, I'm gonna say, 12 units, and minor axis to be, I don't know, I'm gonna say 10 units. Why not? 10 units. Okay, 10 units. All right. Now the thing is, in this case, it's the major axis is parallel. Yes, because I mean, if I just give you the major axis and the minor axis, well, which one is it, the vertical or the horizontal? So it's parallel to the x-axis. In other words, from here we can make up that the ellipse is going to be horizontal. All right. So let's see. Let's see what about this. So number one, major axis is 12 units and minor axis is 10 units. So from here we get that A equals to 6 and B equals to 5. All right, and this is going to be our starting point to eventually find C using the formula. C squared equals A squared minus B squared. Okay, in this case, C squared equals 6 squared minus 5 squared. C squared equals 36 minus 25, and that gives me 11. And C equals the square root of 11. So we have pretty much everything we need to let's say everything we need to get the equation. So in this case, the equation will be that of x minus h squared over a squared. Notice the a, in this case, it's below it's a denominator of the x variable because the ellipse, it's horizontal. That is, it's parallel to the x-axis. Y minus k squared over b squared, and in this case that equals to 1. All right, so let's see. X minus h, which in this case is given, it's minus -3, that's a plus 3 otherwise, over a squared, which is 36, plus y minus k, which is 7, y minus 7, which is, and divided by b squared, which is 5 squared, otherwise 25. that equals to 1. And that's the equation that we were looking for. Well, now that we are around, why not analyze it? All right. So this is what I'm gonna do. Without doing Cartesian plane, I'm going to just draw a point, which is the center. That's the point negative 3 comma 7. So in this case, these are going to be the endpoints of the major axis. That is 12 units, 6 units, 6 units. Okay, so this point is shifted 6 units to the right, that is at plus minus 6 to this point. So 6 units, I'm going to go from negative 3, I'm going to go negative 3, negative 2, negative 1, 0, 1, 2, and 3 actually. So 3, 7, and subtract 3 to get negative 3, negative 3, negative 9 actually, negative 9 comma 7. All right, what about the co-vertices? So B, which is 5 units. In this case, I'm going to add 5 units, but to the y coordinate. So 7 plus 5, that's 12. That's a negative 3 comma 12. And 7 minus 5, negative 3 comma 2. And for the foci, that's root of 11. C is root of 11. I'm going to move root of 11 units. So negative 3 comma, okay, negative 3 plus root of 11 comma 7. And negative 3 minus, negative 3 minus negative 3 minus root of 11 comma 7. So let's list everything now as we usually did. Okay, this is my ellipse. Center, negative 3 comma 7. Vertices, negative 9 comma 7 and 3 comma 7. Co-vertices, negative 3 comma 2, negative 3 comma 12. And foci. For the foci, we have these ugly looking ordered pairs. Negative 3 minus the square root of 11. By the way, when doing the homework, leave the numbers like this. Do not attempt to put decimals. Your homework, my math lab, it's not going to accept decimals, only exact numbers. And that's about it. And this was another example in which, look at the information that we're given. We're given the orientation, the length of the axis, and the center. And that's about it. And this is a good place to quit. I'll see you on the next video.